We're going to have a look at plotting points on the Cartesian plane. First, let's set the scene and see what we're trying to do with this. So imagine you and I each have a blank sheet of white paper, exactly the same piece of paper, but you are in one room and I'm in another room. I draw a dot on my piece of paper and I want to make sure that you draw a dot on your piece of paper in exactly the same place as mine is. One way I could do this would be to say, let's fold the paper in half and in half again, so we find the center point of the paper. And then I tell you, okay, start at the center point and travel so many steps along to the right, and then so many steps exactly up. And if you follow my instructions exactly, you'll get to the correct point. Now, obviously, we need to agree on what are the size of the steps, right, and all that sort of thing. But this is essentially what the idea of the Cartesian plane is. We're going to be looking at a system that allows us to locate a point on essentially a blank piece of paper, which in mathematical terms is a plane. Okay, so let's have a look at how we start getting our Cartesian plane together. One of the things we need to do is sort of talk about how far to the left or right we go. So we're going to draw a line that goes from left to right horizontally, and we're going to mark a starting point on that, which we'll call 0, and then we're going to measure exact little steps, and each step has to be exactly the same size. And so here I've got showing 9 of the steps to the right. And now if I want to move to the left from my 0 point, I'm going to call those numbers negative. But again, each of those steps is exactly the same size. Now remember also, when I was locating that point on my piece of paper, you also needed not only to know how far left or right, but also where up or down it was. So I'm going to put on a line for showing how far up and down you are. And that is going to go through at that same 0 point, and I'll use that 0 point as the 0 point for my vertical line too. And again, I'm going to put steps, each exactly the same size going up, and then I'm going to put steps going down, and the ones that go down I'm going to label as negative. And there I have what is called my Cartesian plane. Let me just talk about a few little terms that we use. First of all, we label that line that goes from left to right, the horizontal line, we label it with an X. We call it the X-axis, and it is the horizontal line. In other words, the line that's going left to right. The line that goes up and down, well, that we're going to label with a Y. We call it the Y-axis, and it is vertical, right? It's the vertical axis that goes directly up and down. A very special point is kind of that starting point where we started the numbering from, both on the horizontal and on the vertical axis. So that 0 point, we call that the origin. Now I'm going to put a grid behind my Cartesian plane because that's going to make it easier for me to work with. And I want to show you how we're going to talk about points on the Cartesian plane. So the way we talk about points is as follows. We give them a name, like A, and then we give them coordinates. The first coordinate tells me the X value, and that tells me how far left or right of that origin, the 0 point, we have to go. The second coordinate is the Y coordinate, and that one tells me how far up or down from the origin we need to go. Let's have a look at it in practice. We always start at the starting point, the origin. Then we start with our X, which is the first number of the coordinate pair, so it's the 4, and that tells me how far left or right to go. So we first just do a nice calm walk along the flat old left to right. And if it's 4, a positive 4, we must move to the right. So we move 1, 2, 3, 4 steps to the right. Then after that, we look at the y coordinate, and that tells me how far up or down I need to go. In this case, it's a positive 5, so I need to go up, so I'm now going to walk up 5 steps. 1, 2, 3, 4, 5. And so over there is my point A, which has the coordinates 4, 5. Let's have a look at another point. If we're asked to plot the point B, which is -2, 3, what do we do? Well, we always start first with the x coordinate. We also always start right at the origin, and then we have to move left or right according to the x coordinate. Now in this case, the x coordinate is -2. Negative means we move to the left, so we must move 2 steps to the left. 1, 2. Then we look at the y coordinate. Y coordinate tells us how far up or down to go. And in this case, the y coordinate is 3, so we need to move 3 steps up. 1, 2, 3, and there we have our point B, which is at -2, 3. Okay, say we needed to draw the point C, 6, -5. Why don't you quickly try now and see if you can identify where that would be on this Cartesian plane. Quickly see if you can point to the correct spot. Okay, let's work on that together. We start at the origin, and then we need to first deal with the x, which tells us how far left or right to go. In this case, it's 6, a positive 6, so it's 6 steps to the right. So we're quickly going to go there. Then we look at our y. Our y tells us how far up or down to go. And in this case, it's a -5, so we need to go down 5 steps. And there we end up with our point C, 6 minus 5. Did you get that right? How about trying this one? See if you can identify where the point D, which is given by -8, -2. Okay, let's see if you got it right. As always, we start at the origin. Then we have a look and see that our x-coordinate is -8. That tells us how far left or right we must move. Because it's negative, we've got to go left, and we've got to go left 8 steps. So let's quickly do those 8 steps. Then we look at our y, and our y tells us how far up or down to go. In this case, it's a -2, so we need to go 2 steps down. So let's quickly take those 2 steps down, and that's where our point D is. Okay, let's have a look at our final point, and this is an interesting one. The point E is 0, 0. So as always, we start at the origin. Then we have to have a look at the x-coordinate, and it tells us we must go no steps, 0 steps, left or right. So we mustn't move left or right. Okay, fine. Then let's look at the y. Well, the y is also 0. So that tells us how far up or down we must move. And this says we mustn't move up or down, 0 steps up or down. And so, in fact, this point 0, 0 is the origin. It's that central spot where the 2 axes cross each other. Okay, so that takes us through the basics of plotting points. The main idea is, when you're asked to plot a point, you always start at the origin. And then you look at the x-coordinate, and it tells you how far left or right to move. And once you've moved left or right, you then look at the y-coordinate, and that tells you how far up or down to move. You move those steps, and where you end up, that is where your point is located. We're now going to look at reading off points from the Cartesian plane. So, if we have that nice little pink point over there, what's the name of that pink point? Well, to get the name of a point, we need to get its x-coordinate and its y-coordinate. So let's start with the x-coordinate. To get the x-coordinate, we need to see how far left or right we've gone from the origin. So what we're going to do is we're going to use the x-axis. That's the measuring stick of how far left or right we go. So let's go straight from that point down to the x-axis, and there we can see that this point is 3 steps to the right of the origin. So the x-coordinate of this point is 3. Then we need the y-coordinate. The y-coordinate is how far up or down you are. We're going to use the y-axis as the measuring stick here of how far up or down you are from the origin. So if we go from the point straight across to the y-axis, we can see that we're on the level that is 5 steps above the origin, and so our y value, our y coordinate of this point is 5. So this point, the pink point we have there, is 3, 5. All right, let's give the name of this one. Again, we first want to get the x-coordinate, and that is how far we are to the left or right of the origin. We use the x-axis as a measuring stick, so we go down to the x-axis and we see that we're 7 steps to the left. In other words, our x-coordinate is -7. We then need to know how far up or down we are from the origin. A y-axis is the measuring stick for that, so let's go across to that, and we will see that we are on a level that's 2 steps up from the origin, and so our y-coordinate is 2, so the name of that green point is -7, 2. Let's have a look at this yellow point now. We want to find the coordinates of this yellow point. As always, we start by looking for the x-coordinate. So to get that, we go down to our x-axis, and we see here that the x-coordinate lies halfway between 3 and 4. So in fact, it's 3.5. And I just wanted to show you this because I want you to be aware that coordinates don't have to be whole numbers. And in fact, as you go on, you'll see your coordinates can be halves, quarters, any kind of decimal in between. Here, it's 3.5. Then we have a look for our y-coordinate, and that we do by going across to the y-axis, and we see that we're at the -4 level. Just a final example, and here you'll see, which is what you will often get, is a coordinates axis without the grid behind. And that's no problem. We don't have to have the grid behind. But then you must just be very careful when you go to read off the point that you go, when you're going up or down, you go exactly parallel to the x-axis or y-axis. You go straight. You don't let yourself kind of deviate off. So let me show you what I mean. If we want this pink point, as always, we start with the x-coordinate, and to get the x-coordinate, we use our x-axis as a measuring stick, and we must just go straight, right? Can you see what I mean by absolutely straight to that x-axis? And here we see that that is at -2. In other words, 2 steps to the left of the origin. And then we need to get our y coordinate, and we do that by using our y-axis as the measuring stick, and we go straight across to our y-axis, and we see that we're at the level that is 6 steps below the origin, so our y-coordinate is -6. Let's play with points on the Cartesian plane. Here I have my Cartesian plane with a whole lot of points plotted on it. First, let's identify which point has the coordinates 4, -3. 4, remember, the first one is the x, which tells you how far left or right you've gone. So in this case, you've got 4 steps to the right. And then your y is -3, which means you've gone 3 steps down. And so the point that has the coordinates 4, -3 is I. Which of these points have a y-coordinate that's bigger than 5? Now remember, your y-coordinate tells you how far up or down you are. So if we want the y-coordinate to be bigger than 5, we want to be any points that are more than 5 steps up. Well, where's 5 steps up? It's that red line. So any points that are more than 5 steps up will be above that line. So we're talking about the points A, B, and C. Now if we're asked which 3 points have the same x-coordinate, what we're looking for there are points that are exactly the same distance to the left or the right. If you look here, these points A, D, and H all are exactly 7 steps to the left. So those 3 have the same x-coordinate of -7. Now if we're asked which 3 points have the same y-coordinate, in this case we're looking for 3 points that are the same distance above or below. Well, if you have a look here, those 3 points are all 4 steps up, and so they have the same y-coordinate, which will be 4. Now if we are asked to plot another point with that y-coordinate, in other words with the y-coordinate of 4, we could plot it there. Another one that is exactly 4 steps up, so has a y-coordinate of 4. And if they ask us to plot another and another and another, well, there's another and another. All of these points, can you see, have a y-coordinate of 4. And in fact, any point that lies on that big pink line will have a y-coordinate of 4. Let's look at some other questions. What if I asked the following? I'm thinking of a point that has a y-coordinate of 0. Where must my point be? Well, with a y-coordinate of 0, it means you haven't moved anywhere up or down, right? In terms of the up-down movement, you've taken no steps. So do you agree with me? You could be somewhere like that, right? At that point, that green dot has not moved up or down. But that is also a place where it hasn't moved up or down. And that's also a place where the y-coordinate is 0. So hopefully you can easily agree that if the y-coordinate is 0, you have to be sitting on the x-axis. All right, what if I were thinking about a point on the y-axis? What can you tell me about my point? Well, if I'm sitting on the y-axis, the y value doesn't have to be anything specific, right? There are many different y values on the y-axis. The thing that doesn't change is the x value. On the y-axis, the x value is always going to be 0, because when you're on the y-axis, you haven't moved anywhere to the left or to the right. Now take a look at that little pink piece that I've covered in. Can you tell me anything about the various points that lie in that pink piece? So just let's look at a few points that lie in that pink piece. There's one, there's another one, there's another one, right? Taking on a whole lot of different y values and a whole lot of different x values. When does it not sit in that pink piece. It's when you move too far to the right. In other words, you're moving beyond x is -5. And so all the points that lie in that pink part have to have their x coordinate being less than -5.